energy. Okay, ma? So first of all, let us try to understand about work done. Okay. So can you define work, ma? Work and define cheyandi. When can you say that work is done? Work jarigindani eppudu cheptaru? See, work has different definitions according to the science which you study. Clear? For example, if you take biology, clear ma? Energy spent. Energy spent, you can call it as work done. You are spending energy, then definitely you can say that you have done the work. For thinking also you need to spend energy, no? Dead bodies cannot think because they don't have the process of producing energy. So if you want to spend energy, then person should be alive. Then we can say that work is done in the case of biology. Clear, Nama? Chemistry. When can you say that work is done? So when any reaction take place, when chemical reactions take place, then definitely I can say that work is done in the case of chemistry. Clear, Nama? But in the case of physics, we have a different definition. Work is said to be done when force displaces a body. Clear, Nama? When force displaces a body, then only work is said to be done. Okay? Or you can say there should be a component of force, there should be a component of force, clear, no? In the direction of displacement. In the direction of displacement or in opposite direction or in opposite direction to the direction of displacement. To the direction of displacement. Are you able to understand, ma'am? So work is said to be done only in this condition. So there should be one component of force in the direction of displacement of the body, or there should be one component of force in the opposite direction to the direction of displacement of a body. Then only work is said to be done. Okay. Now let us try to understand this one by taking one example. See here. For example, this is a body of mass m and I am applying force in this direction, but a body is moving in this direction. Clear? So angle between force and displacement is how much? It is angle theta. Then if I split this force into two components, I can split like this, no? So this is theta, this is f cos theta, and this is f sin theta. Clear now? Now which is the component which is present in the direction of displacement here? F cos theta is present now. So definitely in this condition I can say the applied force is doing some work, because f cos theta is in the direction of displacement. So in the direction of displacement there should be a component of force. That's what we have written now. So definitely in the direction of displacement there is one force component. Clear now? Similarly, if I take the same body of mass m, so body is moving in this direction, but I am applying force in this direction. Okay. Now here this force is making again angle of theta with respect to horizontal, with respect to negative x-axis. Then in this condition also the same force again I can split into two components. No? Clear no? So this is also angle theta, this is f cos theta, and this is f sin theta. Clear? Now if you see here, displacement is in this direction, but f cos theta is in opposite direction. No? So then also work is said to be done. Clear? Now if you see here, in opposite direction to the direction of displacement. So there is one component of force in opposite direction to the direction of displacement, then also work is said to be done. Okay. But if you take one more condition, again if you take the same body of mass m, body is moving in this direction, but I am applying force in this direction. Force is making an angle of 90 degrees with respect to displacement. Okay. In this condition, can I split a force into two components such that one component is in the direction of displacement? Can I do that? Are you able to understand? Now this force vector I want to split into two components such that one component should be in the direction of displacement. Is it possible? ఈ ఫోర్స్ వెక్టర్ని స్ప్లిట్ చేసి రెక్టాంగులర్ కాంపోనెంట్స్గా ఒక కాంపోనెంట్ డిస్ప్లేస్మెంట్ డైరెక్షన్లో ఉండే విధంగా స్ప్లిట్ చేయవచ్చా? కెన్ వి స్ప్లిట్? యూ కెన్ నెవర్ డూ దట్. ఓకేమా? Force, any vector I can never split into two rectangular components such that one component is in the direction of displacement. That is not possible. It means this force does not have any component in the direction of displacement. Okay. So here I can say work done is 0. Here in this condition you cannot do any work. But definitely you are applying force, no? Force is there. Displacement is also there. But still work done is 0. Okay. Why work done is 0? Because there is no component of force either in the direction of displacement or in opposite direction to the direction of displacement. So in this condition definitely work done will be how much? 0. Okay. Now let us see one more condition. So let us take a body of mass m. Are you able to understand? Body is moving. Force applied is 0. Then in this condition, can I say work is done? Body is definitely displacing. It is moving. But we are not applying any force. Can I say work is done or not? No. Here also definitely work is not said to be done. Because again same concept. There must be one component of force in the direction of displacement. Force is 0, so there is no concept of force in the direction of displacement. Clear now? One more example, I will take the same body of mass m. I am applying force in this direction, but body is not moving. Displacement is 0. Okay. In this condition, can I say work is said to be done? Here also there is no work. Why? Force is definitely present, but displacement is not there. So only in these conditions only I can say work is said to be done. There should be force also. There should be displacement also. Both should be present. And force should be, or at least one component of force, should be in the direction of displacement or in opposite direction to the direction of displacement. Then only work is said to be done. Okay, ma? So therefore, what is the formula for work done which we write? The equation for work done is W is equal to Fs cos theta. This is the equation. Are you able to understand? Ma? Clear now? So work is said to be done when there is some force. Force is displacing the body, and angle between force and displacement should not be 90 degrees. Okay? Angle between force and displacement, if it is 90 degrees, then what will happen? Cos 90? Cos 90, 0. So total work done will become 0. So theta should not be 90. It can be other than 90, no problem. It can be 91 also, it can be 89 also. But 90 should not be present. Clear? See ma here, then this work done I can say it is positive work done. Why I can say this one is positive work done? This work done you can say positive work done. How can you say it is positive work? Because there is one component of force in the direction of displacement. F cos theta is in which direction? Displacement direction. Then work done is positive. And what positive work can do? What is the use of positive work? Positive work valla em jarugutundi? With the help of positive work done, the speed of the body increases. That's what happens. Or you can say body sets into positive acceleration. Body is moving in towards positive x-axis. You are also applying force in positive x-axis. Then what happens to the velocity of the body? Increases, speed increases, velocity increases, there is acceleration. That is what happens, no? So when speed increases, such kind of work done you can take it as positive work done. Clear, no? Now what about this one? This is definitely negative work done, no? How can you say it is negative work done? Negative work. How can you say it is negative? Because body is moving in one direction, but F cos theta is acting in opposite direction. No? So therefore, with the help of this F cos theta, speed of the body increases or decreases? Speed decreases. If speed decreases, such work done you should take to be negative work done. Okay. Then what about this one? Work done is 0 because work is not at all done here. It means in this direction, speed doesn't increase, speed doesn't decrease also. That is called as zero work done. In kinematics also same concept we have studied. In kinematics what we have studied, body is moving in one direction, gravitational force is pulling the body in downwards direction. So horizontal velocity of the body you can never change. That's what we have studied. No? Horizontal velocity of the body cannot be changed by gravitational force because body is in horizontal direction, gravitational force is in 90 degrees, at an angle of 90 degrees it is acting. So that is zero work done. Clear? No? So this is positive work, negative work, and this is 0 work. So here what you will write, you have to write speed of the body and velocity of the body increases. It means there is some acceleration here, positive acceleration. What about this condition? Speed of the body, velocity of the body decreases. It means retardation is present, negative acceleration. What about in this condition? There is no acceleration. Work done is 0, so there is no acceleration. Clear number? Right. So make the statements of your own. So what is the equation for work done? We have written equation for work done is W is equal to Fs cos theta. This is the equation number. So this equation we can use in which condition? This equation can be used when force is a constant. Clear no? When force is a constant, then only we can use this relation. It means we are applying same amount of force on the body. Clear? For example, if you are applying 4 newtons of force, throughout the motion you are applying 4 newtons only. Then you can use this relation W is equal to Fs cos theta. Clear? So, if a force is not a constant, then what we have to use? If a force is a variable. Clear? If force is varying with respect to time, then in that condition what I have to write? Then I have to write a W is equals to integration of F dash dot ds dash. Okay? Or you can write integration of F ds cos theta. Limits are applied from S1 to S2. Okay? So this is the equation I can use when force is a variable. Okay? Are you able to understand? So W is equals to integration of F dash dot ds dash. In which condition? When force is a variable, when force is varying with respect to distance. Okay? Then we are supposed to use this relation. And what is meant by theta here? Theta is again the angle between force and the small ds, differential displacement which you are taking. Fine? Okay. So let us write some equations or questions regarding this one. For example, if I give you a question like this, clear now? So force acting on a particle is according to F is equals to 3s square plus 4s plus 1. Okay, ma? So find the work done in moving a body along x-axis from s is equals to 0 to s is equals to 3 meters. Okay, ma? Force is in which direction? Force is along positive x-axis. Clear? This is the question. Come on, try to answer this question, ma. Got the answer, ma? Anybody? See, ma, in this condition, force, is it a variable or is it a constant? Definitely variable, no, because when s value changes, that is when displacement changes, force also will changes. Force is not a constant, for definitely force is a variable. Clear now? So if a force is a variable, we have 2 equations of work done, no? So this is one equation, this is one equation. Which one shall I use? Definitely this equation I cannot use because force is not a variable. Clear now? So therefore I will use the relation W is equals to integration of F dash dot ds dash. Limits are applied from S1 to S2. Fine. Now same equation, see ma, this equation is of which form? Cross product form or dot product form? This one. Definitely dot product, no? A dash dot B dash is equals to AB cos theta. Dot product only, no? So therefore this one I can write it as F dash dot S dash also if I want to represent this one in the form of vectors. Clear? Similarly, this one also I can write the general formula. No? What is the general formula? So integration of F ds cos theta. Limits are applied from S1 to S2. Clear? So force is how much? Force is 3s square plus 4s plus 1. This is force. Then you write ds, then you write a cos theta. Clear now? Then force is applied from where to where? I want to calculate work done from s is equal to 0 to s is equal to 3. So limits of integration are 0 to 3. Clear? Now do the calculation. Now here can you say what is theta value? 0. Why it is 0? Because force we are acting towards positive x-axis. Body is also moving along the same direction. So in this condition theta is how much? Theta is 0 degrees. Cos 0 value is 1. Clear? Now do the calculation. So therefore work done is how much? So therefore work done is equals to integration of 3s square. Integration of 3s square is 3s cube divided by 3. That's all. Integration of 4s. 4s square divided by 2. Clear now? Plus integration of 1 is how much? Integration of 1 is s. Clear? And limits from where to where I have to apply my limits from 0 to 3. Now just substitute these values, then you will get the answer. So w is equals to s cube plus 2s square plus s. So limits are applied from 0 to 3. So w is equals to 3 cube plus 2 into 3 square plus 3. Clear now? No need of applying 0 here because everything will become 0. So 27, 18 plus 3. So 48 joules of work is done. So that is our answer. Clear now? Have you understood, ma? So this is how. So this is the equation question which is given, ma. So force is given, and body is displaced from which position to which position? It is displaced from R1 dash to R2 dash. Clear now? Then we are supposed to calculate the work done. So R1 dash to R2 dash means, what is R1 dash initially? First position of the body. Which is the second position? R2 is the second position. Change in position, how can you calculate? Change in position. R2 minus R1 becomes the change in position. It is not R1 minus R2. అర్థమవుతుంది కదా? Change means you should never write R1 minus R2. Change means what? Final value minus initial value. If final value is greater, change will become positive. If final value is lesser, change will become negative. Clear? So change means whatever it may be. Change in volume, change in pressure, change in temperature, change of displacement or change of position. Anything you should take final value minus initial value. So therefore, what is the change in position? Change in position, which is also called as displacement. Change in position is nothing but displacement only, no? So therefore it is R2 dash minus R1 dash. Final value minus initial value. Clear? What is the final value? 4. So 4 minus 2 I cap plus 2 minus 1 j cap plus 3 minus 1 k cap. These are the values which I got now. Clear? Now do the calculation. So it is a 2 I cap plus j cap plus 2 k cap. So this is the displacement of the particle. Clear now? So I can write S dash. S dash is nothing but displacement. Displacement is given by this relation. Okay. Now see my here, given force, is it a constant or is it a variable? Constant value only, no? There is no concept of variables here. Force is along x-axis also, force is along y-axis also, force is along z-axis also, but whatever it may be, force is a constant. Clear? If force is a constant, then what is the equation? W is equal to F dash dot S dash. Why am I writing this one? Because everything I have been given in vectors only, no? So write the equation in vector form. Clear now? Force equation, so 10 I cap plus 2 j cap plus 3 k cap. Dot product of displacement is 2 I cap plus j cap plus 2 k cap. Clear now? So what is the formula to calculate dot product of two vectors? X1, x2 plus y1, y2 plus z1, z2 if it is given in component form. Vectors are given in component form only, no? So the equation of dot product is x1, x2 plus y1, y2 plus z1, z2. That's all. That is my equation. Now substitute. So there is no concept of I cap now. Just you will get magnitudes only. Work done is a scalar quantity, no? Work done is what kind of quantity? Is scalar. So you will get answer only in terms of magnitudes only. There is no concept of I cap, j cap and k cap in the final answer. Okay. So 10 into 2, 20 plus 2 into 1 plus 3 into 2. So total how much? 28. So 28 joules of work is done. That's all. That is our answer. Fine. Very simple. Still okay. Work done by applied force, work done by friction, work done by net force. 3 values you are supposed to calculate. See here, 2 kg body is present on a surface where friction is present. Friction is there. Okay. Then friction also will do some work. No? So I want work done by applied force also, frictional force also, as well as net force also. Work done by 3 forces I want to calculate. Fine. Come on. So first work done by applied force. Okay, so work done Fs cos theta. Force is a constant, you know, so I can use Fs cos theta. Force is 10 Newton, displacement is 5 meters, angle between force and displacement is cos 0. So 50 joules of work is done. So that is the work done by applied force. Clear number? Then I want to calculate work done by friction. Okay. So work done by friction, again Fs cos theta. Small f indicates frictional force. Clear now? Friction is how much? So this is a 2 kg body. Clear now? Weight of this body is a 20 Newton. 20 Newton falls on the ground. So normal reaction is also 20 Newton. So if body is in movement, definitely limiting friction should have developed. Limiting friction value is how much? It is mu s into n. So mu s value 0.4. Normal reaction is 20. So 4 2s are 8 Newton is the limiting friction. Clear now? So work done by limiting friction. Work done by limiting friction, Fs cos theta. So friction is 8, displacement is 5. Angle is 180 degrees, no? Why angle is 180 degrees? Because body is moving in one direction, friction is acting in opposite direction. Clear now? So therefore 8 5s are 40. So minus 40 joules of work is done by frictional force. Clear? So next, work done by net force. Work done by net force. Clear now? So on this body, what is the net force which is acting? Net force is how much? Clear? 2 newtons is the external force in this direction. In opposite direction, what is the frictional force? 8 Newton. So net force will become how much? 10. 10 minus 8, 2 Newton. Clear now? So if you take this body of mass 2 kg, F external force is 10 Newton. Clear now? Frictional force is how much? 8 Newton. So therefore net force acting on this body is 2 Newton. So therefore work done by net force. So net force multiplied by displacement multiplied by cos theta. So net force is 2, displacement is 5, angle between them is 0. So 10 joules of work is done. That's it. Or just you can do one thing, you can add these two also. 50 plus of minus 40. Then also you will get 10 joules of work only. Clear now? 50 joules is the work done by applied force. Minus 40 joules is the work done by friction. Add both of them, you will get again plus 10. That's it. Like that also you can do. So let us see this question. So this is the given problem. 5 kg body, force of F is acting. And how much is that force? I don't know. Angle is 37 degrees. Coefficient of friction is 0.25. Clear now? So with the help of this force, if I move the body a displacement of 4 meters, then what is the work done? That is the question. And the most important point here is that body is traveling with a constant velocity. What is meant by constant velocity? Acceleration is 0. That is the meaning of this one. What is meant by acceleration is 0? Constant to acceleration 0 constant acceleration. Acceleration is 0 means what? Net force acting on the body is 0. That is meant by constant acceleration. There is no net force. Net force is 0 means all the forces along x-axis, all the forces along y-axis, they are balanced with each other. That is the meaning of this one. So this much information you should get when you see that acceleration is a constant. Sorry, velocity is a constant. Clear now? So first of all, let us see how I can do this problem. So you take this force. Force is not along x-axis, it is not along y-axis also. No? Split this one into two components. Clear now? So this is angle 37 degrees. So this is F cos 37 and this is F sin 37. Clear now? Now you draw the free body diagram of this 5 kg body. On this 5 kg body, how many forces acting? So one horizontal force F cos 37 is acting. One vertical force F sin 37 is acting. One force is weight of the body 50 newtons is acting. But total weight doesn't fall on the ground, only some of the weight falls. So some normal reaction is acting in upward direction. If body tries to move in this direction, limiting friction starts acting in opposite direction. So these are the different forces which are acting on this body. That's all, no? Fine. Force we have split into two components, F cos theta, F sin theta. Clear? Weight 50 Newton is acting down. 5 kg body, no? 50 Newton will be acting downwards. But total weight doesn't fall on the ground. Total weight doesn't fall on the ground. Why? Because there is one upward force F sin theta which is pulling the body upwards. No? Already we discussed, no? When some force is pulling the body in upward direction, total weight of the body doesn't fall on the ground. Only some of his weight will fall on the ground. Clear? No? So how much is that weight? I don't know. So normal reaction also I don't know. Okay, ma? And friction always tries to act in which direction? In the direction to opposite direction to the movement of the body. Body tries to move along positive x-axis, no? Friction will act along negative x-axis. So these are the different forces which are acting. Okay. Now velocity is a constant, no? velocity is constant means what? Net force is 0. Okay, ma? Net force formula, mass into acceleration is 0. So therefore I say acceleration is also 0. Okay. So acceleration will become 0 in which direction? When all the forces are balanced. All the forces are balanced. Then in this condition only, you can say net force is 0. Clear? What are the forces along x-axis, ma? Along x-axis, what are the forces which are acting? Along x-axis, F cos 37 and limiting friction. These are the two forces, no? Clear, no? So therefore I will write F cos 37 and limiting friction, they must be equal to each other. They must be equal. If they are not equal, then what will happen? If they are not equal, force is unbalanced, so net force will be created. But net force is 0. So forces must be equal and opposite. Fine. So limiting friction formula, mu s into n. Okay. So therefore to calculate F value, first of all I require a normal reaction. Normal reaction also I don't know. So what I will do, so again you take along y-axis. You take equation along y-axis. Clear now? Along y-axis, what are the forces which are balanced? Normal reaction is in upward direction. If sine 37 is also in upward direction, 50 newtons is acting in downwards direction. So therefore, F sine 37 plus normal reaction, these two must be balancing the weight of the body. That's all. Clear now? So from here you calculate normal reaction. Normal reaction is how much? 50 minus F sine 37. Okay. So I calculated equation for normal reaction. So take this normal reaction, substitute here. Okay. If I substitute there, then let us see what will happen. So F cos 37 is equals to mu s into, instead of normal reaction I will write 50 minus F sine 37. Clear number? So therefore if you take all F values on one side, so F cos 37 plus mu s F sine 37 is equals to mu s into 50. So this is the equation which I will get. I want to force only, no? So you do one thing, you take force common here, then if you take force common, then I will get cos 37 plus mu s sine 37 is equals to mu s into 50. Clear number? Therefore you calculate F value. So F value is mu s into 50 divided by cos 37 plus mu s sine 37. So mu s value 1 by 2. 1 by 2 into 50 divided by cos 37 is 4 by 5 plus 1 by 2 into sine 37 value is 3 by 5. Okay, ma? So calculate F value. Then very easily I can calculate F value number. Once you calculate F value, then can't I calculate work done? Work done by external force only, no, he is asking. So work done formula Fs cos theta. Force is here I will get force. Displacement already he gave 4 meters. Clear number? Angle already he gave, it is 37 degrees. Okay. So cos 37. So calculate the work done, that is our answer. So very simple. Okay. So just within 30 to 40 seconds you can do this calculation. If you are very good about what is happening, if you understand physics. Clear ba? So therefore force you should get 250 divided by 11 Newton and work done you should get 800 divided by 11 joules. So those are the answers. Okay, ma? Okay. So let us see this question, ma. So a block of mass 2 kg is brought down by a string. If the block acquires a speed of 1 meter per second in dropping down by 25 centimeter, then find work done by the string in the process. That's what he is asking. No? So let us try to understand. No? For example, if this is a pulley system, then this is a block. Okay. So this wire is wound to this pulley, and other end of the wire it is connected to a block of mass 2 kg. So if I release this system, it starts accelerating downwards now. What are the forces acting on this 2 kg body? First, its weight 20 Newton will be pulling the body downwards. Tension will be acting in upward direction. That's it. Now if it is accelerating downwards, it means definitely 20 is greater than tension. Clear now? If it is accelerating downwards, it means 20 Newton should be bigger than tension. So how can I write a net force relation here? 20 minus T is equal to net force. Net force formula, mass into acceleration. This is how we can write now. So 20 minus T is equal to, mass of the body is 2, acceleration I don't know. So therefore what is the tension I can calculate? So tension is equals to 20 minus 2A. So let it be my first equation. Understood, Nama? So why I am calculating tension? I am calculating tension because he is asking work done by string, you know. String means what? Tension in the string. It means I am supposed to calculate work done by tension. Okay. Now acceleration I don't know. So how can I calculate acceleration? He gave that when I release this one, block acquires a speed of 1 meter per second in dropping by 25 centimeter. It means take the help of kinematics. So v square minus u square is equals to 2as. Final velocity already he gave 1 square. Initial velocity 0. Acceleration I don't know. Displacement is 25 by 100. Centimeters he gave nama, so 25 by 100. So therefore 1 is equals to 2 into a into 1 by 4. So therefore a is equals to 2 meters per second square. That is the acceleration of the block now. Okay. Once I calculate acceleration, take this acceleration and substitute here. Fine. So therefore t is equals to 20 minus 2 into acceleration is 2. So t is equals to 20 minus 4. 16 Newton is the tension. Okay. So first of all, what I have calculated by using Newton's laws and by using kinematics, we have calculated how much tension has developed in the string. Okay. So once I calculate the tension, now very easily I can calculate work done. No? Work done by tension is how much? Fs cos theta. So force applied is nothing but a tension. Displacement is yes, and angle is cos 180 degrees. Tension is how much ma? 16. Displacement is how much? 25 centimeters. No? So 25 by 100 multiplied by cos 180 value is minus 1. Clear? So therefore work done by tension. So 25 force and minus 4 joules of work is done by tension. That's all. It means a string is doing this much amount of work. Fine ma? Okay. So now if I ask you the question, what is the work done by gravitational force? Calculate that also. Second question which I am giving is work done by gravitational force is how much? Can you say? Gravitational force ఎంత వర్క్ చేస్తుందో చెప్పండి. Work done by gravitational force. Gravitational force means what here? Weight of the body. Clear nama? So work done by gravitational force is nothing but again gravitational force multiplied by displacement into cos theta. Gravitational force is nothing but weight of the body. No? Clear nama? Displacement is again 25 by 100. Angle is cos 0. Why cos 0? Because displacement and force, both of them, they are acting in same direction. Gravitational force is downwards. Displacement is also downwards. Cos 0. So again 20 by 4. How much more? 5. 5 into 1. So 5 joules of work is done. That's all. Are you able to understand? That's all very simple. Clear? So this is the given question. So here this system, it is released from rest position. Then we are supposed to calculate work done by the gravitational force during first 2 seconds of motion. It means when I release this system, in the first 2 seconds, what is the work done by gravitational force? So this is what kind of system? This is what kind of system? This is an Atwood machine. Already we have studied Atwood machine. When a pulley is present and 2 masses are suspended by 2 ropes, it is called Atwood machine. Clear? And already we calculated in Newton's laws the acceleration of Atwood machine. No? What is the acceleration of Atwood machine? m2 minus m1 divided by m1 plus m2 into g. This is the acceleration. No? Or if you don't know this one, then always you can do by Newton's laws. So write one Newton's law equation for a 3 kg body, write one equation for a 2 kg body, solve both of them, then you will get acceleration. Already we have done. No? Okay. So therefore what is the acceleration I got? Mass is, bigger mass is 3, smaller mass is 2, 3 plus 2 is 5, g value is 10. So how much more? 2 meter per second square. So this is the acceleration produced. It means this body starts coming down with an acceleration of 2 meter per second square, and this starts moving upwards with an acceleration of 2 meter per second square. Okay. So once they are accelerating, to calculate work done, I need force also, I need a displacement also, I should know angle between them also. No? So force we will calculate afterwards. First I should calculate displacement. No? So it means in 2 seconds bodies will move by how much distance? First of all I require that one. No? Are you able to understand? How can I calculate? This is accelerated motion. No? So I will use the relation S is equal to ut plus half at square to calculate a displacement. So displacement is equal to initial velocity 0, half into acceleration is 2, time taken is how much more? 2 seconds. So 2 get cancelled. So displacement is equal to 4 meters. Okay. So what is meant by displacement is 4 meters. This block comes downwards by 4. This block moves upwards by 4. That is meant by displacement 4 meters. Now tension. So work done by whom he is asking? Sorry, not tension. Work done by gravitational force he is asking. Okay. So work done by gravitational force. Displacement of each body already we have calculated. Now you take for example 2 kg body. Okay. So on this 2 kg body, gravitational force is how much? 20 Newton. Gravitational force is nothing but weight of the body, 20 Newton, mg. Displacement will be in which direction? Displacement will be in upward direction. No? Bigger body comes down, smaller body moves upwards. So displacement is how much? Displacement is equal to 4 meters. It is in upwards direction. So therefore, calculate work done in this condition. So W is equal to Fs cos theta. So force is 20, displacement is 4. But what is the angle between force and displacement? 180 degrees. So cos 180 is -1. So minus 80 joules of work is done. That's all. So therefore, gravitational force is doing negative work on which body? 2 kg body. Negative work only, no? Because body is coming downwards. Body is moving upwards, but gravitational force is acting in downwards direction. Clear? Similarly, you calculate for 3 kg body. 3 kg. Okay. So on 3 kg body, clear number, how many forces are acting? It's one weight 30 Newton. And this body will come downwards number. Here displacement 4 meters will be in downwards direction. So again calculate work done. So again Fs cos theta. Force is 30, displacement is 4, angle is cos 0. Cos 0 value is 1. So 120 joules of work is done on 3 kg body. So it means gravitational force is doing positive work on one body, negative work on another body. Clear now? So what total work done by gravitational force is how much? Total work done is 120 minus 80. So how much more? 40 joules of work is done. Okay. So 40 joules of work is done by which force? Gravitational force. Okay. And positive I got, negative I got. Positive value. What is meant by positive value? It means on the whole, gravitational force is doing positive work. Okay, ma? It is doing greater positive work on one body, lesser negative work on another body. But on the whole, it is doing positive work only. If positive work is done, it means that center of mass of this body moves downwards. Center of mass of this body, what happens, ma? It moves downwards. Okay. So that is according to center of mass reference frame. So here, what are the note points we have to write, ma? Note points are, write down. Gravitational force does positive work on one body and negative work on another body. Okay, ma? So note point is that gravitational force does positive work and negative work also. Okay, but positive work is greater than negative work. Okay, so therefore net work done by gravitational force is positive. Therefore center of mass of system moves downwards. Okay, ma? If you do positive work on any body, then body should move in that direction only, no, ma? So for this system, there will be one center of mass. That center of mass finally it moves downwards because gravitational force is doing positive work. Okay, so we will understand this in more detail when we study center of mass. Okay, so see, my next concept which we are studying is area under Fs graph. Clear? See, what is the equation for work done? W is equal to Fs cos theta. No? This is the equation for work done. No? In which condition? When force is a constant. When force is a constant. What is the another equation when force is a variable? No? So W is equals to integration of F dash dot ds dash. Limits are applied from S1 to F2. In which condition? When force is a variable. Already we have studied this one. No? Okay. Now this equation, it is looking like what? It is looking like area is equals to length into breadth. No? This is also looking like. See, now this formula, it is of which kind? It is of the form of area is equals to length into breadth. No? So whenever you see equations of this format, Already we discussed many times, no? If you take the area under length and breadth, it will give the parameter which is present on the left hand side. Clear, no? It means if you take the area of the graph under force and displacement, then what you will get? Then you will get the work done. That's it. Clear? So therefore what I write? So if equation is of the form of, clear, no? So area is equals to length into breadth. Okay? Then the area under L and B gives the magnitude of parameter on left hand side. Okay, ma? So that is the condition. Okay. So what is the meaning of this one? So what is the area under this FS graph, ma? This is the area, no? So this is the area under FS graph. Clear? So therefore, how can I write? I can write area is equals to length into breadth, or you can say just area under FS graph will give work done. Okay, ma? For example, if I draw a graph like this, so this is force and this is displacement. So graph is like this. So let force be 10 Newton, okay, ma? And displacement is let it be 10 meters. Then in this condition, can you say how can I calculate work done, ma? How can I calculate work done in this condition? Huh? How? What did I say? I said that area under the graph. Pythagoras theorem. ఏం చేయమంటారా 10 to 10 యాడ్ చేద్దామా area under this graph, this is the force displacement graph. Now how can you calculate area under this graph? What kind of area is this? It is a triangle, no? Area of the triangle, half into base into height, that's all, no? You are supposed to calculate area, that's all. Okay, ma? You forget about these equations here. When graph is given, you are supposed to calculate area under that graph. Clear, no? So here what is the area? Area is nothing but this is the shape of a triangle, no, ma? So we will write half into base into height. So base is 10, height is also 10. So therefore 50 joules of work is done in this condition. Okay. Now is it a variable force or a constant force? Huh? Variable force. Force is changing, no, continuously. Magnitude of force, it is changing continuously. Clear, no? So definitely this is an example of a variable force. But if a graph is given, definitely you can just find out the area under the graph. That's it. Fine. Sima, let us see this question. So this is the graph given between force and displacement. Okay. Then he is asking us to find out the work done. So how can I calculate work done when a graph between force and displacement is given? Just to calculate area under the graph. That's all. Now Sima, here graph up to here, graph up to 25 meters, it is present in first quadrant. No? Clear, no? But this graph which you are seeing, it is present in fourth quadrant. So we should be careful about that also. Graph is present in which quadrant? Why it is like that? Sima. For example, if you take this is plus f, this will become minus f, no? Clear, no? If you take this is plus s, then this will become minus s. So what is the formula for work done? Force into displacement. Positive force, positive displacement. Here work done will be positive. Clear, no? Then here what about in the second quadrant? What about the work done? Positive force, negative displacement. Force into displacement, negative work done, minus W. So in second quadrant work done will be negative. Are you able to understand? Third quadrant, displacement is also negative, force is also negative. Negative into negative, positive. So here work done will be positive in third quadrant. Again if you take fourth quadrant, minus into plus, minus, negative work done. Okay, ma'am? So therefore in first quadrant and third quadrant, if graph is present, then that graph is positive. It means a positive work will be done. Fine. If you take second quadrant and fourth quadrant, then here work done is negative. It means negative work is done on the body. Clear, no? So therefore first and third quadrants, clear, no? So here what I can say, so here work done will be positive. First and third quadrants. Second and fourth quadrants, work done will be negative. Clear now? So negative work will be done. Okay. Now if you see this graph, from here to here, this total graph is present in positive quadrant. That is first quadrant. But what about the area under this graph? This graph is present in fourth quadrant. So that work done will be negative. So first of all, calculate this total work done. From this total work done, you remove this work done. Then you will get the net work done. Fine. Now let us divide this figure into some equal parts, some parts where we know their shapes. Clear now? So this one I will calculate as first area, second area. Then if you want, you can split this one into area number 3, area number 4. This total is area number 5 and this is area number 6. That's all. So calculate what is the work done under first graph. Work done W1, force half into base into height only. No, this is triangle, no? So therefore half into base is 5, height is 4. Okay. W2, so this is in the shape of a rectangle. So length into breadth. So 10 minus 5, 5 is the length. Clear number? Height is how much? Height is 4. So 5 4s are 20. Work done under third graph, 15. 15 minus 10, again 5. Height is 4. So 5 into 4. Work done under area under fourth graph. This is a triangle, no? What is the area of a triangle? Half into base into height. Half into base is 5. And this height I require. What is this height? 10 minus 4. 10 minus 4. 10 minus 4, 6. Clear number? So work done under area 5. So half into base. Base is 25 minus 10. 25 minus 10 is 10. Height is 10. Clear number? And area under sixth graph. Again this is a triangle only, no? So half into base into height. So half into base is 5. Height is 5. Are you able to understand? So just to do all these calculations, add 1, 2, 3, 4, 5 and from all of them you remove this sixth area. Then you will get the total work done. Clear number? So this is 10, this is 20, this is also 20, this is 15, this is 50 minus 25 by 2, 12.5. Clear number? So see how much total it is? 115 minus 12.5. Correct only, no? So therefore how much it is now? So 102.5 joules. That is my answer. Fine? That's all.